So today our coordinate proofs, we're going to be focusing in on squares. What is a square? What type of properties do they have? And what does it look like in a proof form? So our basic definition of a square is a quadrilateral with 4 right angles and 4 congruent sides. In other words, all sides are congruent. So using that definition, it says based on that definition, which of the following types of quadrilaterals, or a square, I'm sorry, is which of the following types of quadrilaterals? So a quadrilateral that has 4 right angles and 4 congruent sides is a square. So that means, well, it has to be a rectangle, and the reason is, well, it has 4 right angles. So rectangle has 4 right angles, square has 4 right angles, so yes, a square has to be a rectangle. Another important property that they both have is they both have congruent diagonals. Okay, so a rhombus. A rhombus is a quadrilateral with 4 congruent sides. So yes, a square is a rhombus because it has 4 congruent sides. Now, other properties that they also both share is both of them have diagonals that are perpendicular. And both of them have diagonals that bisect not only each other, but more importantly, opposite angles. Parallelogram is a quadrilateral with 2 sets of opposite sides parallel. A square definitely has that, so I can say yes. It has 2 sets of opposite sides parallel. Diagonals will bisect each other. And each of these shapes have that characteristic. And then lastly, a trapezoid. Trapezoid's definition is a quadrilateral with at least 1 set of sides parallel, which a square definitely has since it also has the 2 sets. So I can say yes because that characteristic is at least 1 set of sides are parallel. So I can see it looks like all 4 of these. And if we go back to that flow chart that we got in the beginning of our quadrilateral section, we said if we read it bottom up, the word we could use is all. Square is at the bottom, and I can read it up, and I can say they are all. Okay? A little bit of algebra. So it says the lengths of the diagonals of a square are represented by 2x plus 3 and 4x minus 11. And it says find the value of x. Well, up above, we said diagonals were going to be congruent. So if that's the case, if they are equal, we always say if they're equal, set them equal and solve. So if we were to solve this, I could subtract over the 2x. This leaves me with 3 is equal to 2x minus 11. I could add over the 11 on each side. And this is going to show me I have 14 is equal to 2x. And so therefore dividing by 2, I can find x is equal to 7. So diagonals of a square are equal. I can plug that in and I can check it if I wanted to. So I could say 2 times 7 plus 3, it should equal 4 times 7 minus 11. That's our check, right? So 2 times 7 is 14. 14 plus 3, I'm going to get 17 on this side. 4 times 7, I have 28. 28 minus 11, I get 17 on this side, so it checks out. Okay, now on to the back with our coordinate proof. So first thing I would do is I'd say plot the picture so that you can see what it looks like. Make sure that you're labeling it. Keep in mind, this is not going to be justification. Rather, this is going to try and help maybe spur some thoughts, maybe help get you ideas of which sides are opposite each other. But it's not going to be enough to just say, I've graphed it and it's a square because it looks like it. Okay, so we have to prove it is a square. So from our definition, we know a square has 4 sets of congruent sides, 4 sets of right angles. And right angles are formed by perpendicular lines, and perpendicular lines means I want to test slope, and I want to make sure that they have negative reciprocal slopes. So if I were to just start with AB, look at the coordinates, I could have 3 minus 0 over 3 minus a negative 1. So simplifying, I get a slope of 3/4. Now, adjacent to AB is side BC, and it should have a negative reciprocal slope, meaning negative 4/3 is my hope for the answer. So if we test this out, I have 3 minus a negative 1, and I have 3 minus 6. So simplifying, I have 4 in my numerator. My denominator gets me negative 3, and right there I can see that those are negative reciprocal slopes, and that's showing me that I have perpendicular lines. So I need to keep going. I need to keep doing the other two. So I need to find the slope of CD. Same idea, so if I plug it in, I have negative 4 minus a negative 1, 2 minus 6. And if I simplify, I get a negative 3 over negative 4, but I have to reduce my fraction, and that's going to get me 3/4. And now notice what happens. These two also have negative reciprocal slopes, meaning that they have perpendicular lines. And I have one more to go. I have the slope of AD, and the slope of AD I have 0 minus a negative 4, and our denominator negative 1 minus 2. So this would get me, again, 4 over negative 3. And again, I can see that these guys have negative reciprocal slopes. So they have to be perpendicular. So what we have just shown is that I have a four-sided figure with 4 right angles. So I can at least say right now, ABCD has 4 right angles, since all adjacent sides have slopes that are negative reciprocals. And those form perpendicular lines. Now, that's not enough. If we stop there, that would only prove a rectangle. So in order to prove that this is a square, now we have to try some distances. And really and truly, you only need 2 distances. You would need 2 adjacent sides distances, because once I know I have 4 right angles, all I need to show is that 2 sides that touch each other have the same length, and if that's the case, that shows that we have a square. Now, if you're not sure, you can't remember, you're not sure how many to do, you're always better off doing more than not enough, or maybe you're not sure which sides to take. You're always better off doing all 4. Might take a little bit of time, but then at least your work is on your paper. So we're going to do AB and BC. And if we did the distance of AB, I would have a negative 1 minus 3 squared plus 0 minus 3 squared. So when we're doing the distance, keep in mind, simplify your parentheses first. So this gets us a negative 4 squared. This gets me negative 3 squared. Now if I simplify, negative 4 squared, negative times negative, keep in mind that's positive, 16. Same thing over here, this is going to get me a positive 9, which gets me the square root of 25, and I know that that simplifies down to 5. So the distance for AB, the length of AB is 5. We're going to do the same thing for BC, and now the reason I'm taking BC is it's adjacent, it touches. I want to see that 2 sides that touch are the same. So if I were to plug this in, I have 3 minus 6 squared plus 3 minus a negative, that's plus a positive 1 squared. So this, if I simplify, remember simplify first, I get a negative 3 squared. Over here I have a positive 4 squared. So now I have to go back and square them. And this would get me positive 9. Over here, positive 16. When you add, you're going to have the square root of 25, and the square root of 25 simplifies down to 5 because it is a perfect square. So if I look at these two, and again, they're adjacent sides, they have the same distance. I could say same length. I could say that that means that they are congruent in length, same size. All right, and since I did the adjacent ones, that's enough to show it's a square. Now, if you did the other two, I will also tell you they do turn out to be 5, but you could stop here. And this is enough to say, okay, it has to be a square because we found it had 4 right angles up above. So it has 4 right angles. Here's the key thing though. And our adjacent sides are congruent, which means it has to be a square. Now, if you are not sure, please try the other distances. If it makes more sense for you to do all 4, like I said, you're always better off doing more work than not enough. You'd want to show that the distance of CD, again, would be the square root of 25 or reduced to 5. You would want to show the distance of AD also is the square root of 25, which reduces to 5. Okay, maybe that's a little bit easier for you to say I have a quadrilateral that has 4 right angles and 4 congruent sides. You have some options while you're doing coordinate proof. Again, this is not the only way. You could do it through diagonals. You could show me diagonals are perpendicular with slope, that they bisect using the midpoint, and that they are congruent using distance. So there would be another 6 calculations just using all diagonal properties. We'll talk about this more in class and give you some other methods on how you can do this.